Here's my solution for homework 5 question 2. In this question, given the density function of x y equal to 1 divided by a y square x, and y is larger or equal to 1, and x is between 1 divided by y and y. The first question is to draw the non-zero definition region of drive density function of xy. First, we can draw the because first we can draw the line of x equal to y, which is this line, and then we can draw the line diagram of x equal to 1 over y, which is this line. Because x larger than because y larger than 1, so this point is 1, so y need to be above this point, and because x is larger than 1 divided by y, so so x need to stay to the right of this line, and x smaller than y, so x need to be above this line. So this shaded area is the non-zero definition region of density function of xy. The second question is to find a so that fxy is a valid joint density function. In order to make sure that fxy is a valid joint density function, this equation must be true. The integral of density function from 0 to infinity is equal to 1. We can calculate this integral, and finally we get this equation. So the value of a must be 2 to ensure that fxy is a valid joint density function. And the third question is to find and draw the marginal density function of fx and fy. From the book, we know that the density function of x is equal to integral from minus infinity to infinity fxy dy. In order to there are two cases for this calculation. For x between 0 and 1, the density function of x equal to integral from 1 divided by x to infinity 1 divided by 2 y square x dy equal to the half. 1x is larger than 1, the density function of x is equal to 1 over 2x squared. So we can draw the diagram of density function of x, which is like this. Here is the half, and its point is 1. then we calculate the density function of y. It's same as the density function of x, which is equal to the integral of density function of xy, which is equal to log base e of y divided by y squared. This is the value of when y is larger than 1. If y is smaller than 1, the density function of y is equal to 0. So the diagram is like this. Here is the 1. In the last question, we need to verify the density function of x and y are valid density function. In order to make sure that density function is a valid density function, we need to verify that the integral from 0 to infinity of density function is equal to 1. According to the calculation, the density function of x and density function of y are all valid density function. Here's the solution for question 2.